Hello good people, I'm going to demonstrate a few examples where I will use visual representations to deal with the data or information given. The first example looks at cosmetic procedures. According to the International Society of Aesthetic Plastic Surgery, the following were the top 5 procedures in the world in millions for the year 2024. For women, liposuction with 1.8 million procedures, then blepharoplasty, which is essentially eyelid surgery with 1.6 million procedures, mammoplasty or breast augmentation with 1.6 million procedures, abdominoplasty or the tummy tuck with 0.9 million procedures, and scar revision with 0.8 million procedures. For men, the top 5 procedures were blepharoplasty, mammoplasty, scar revision, liposuction, and rhinoplasty. If I'm going to present this information visually, one of the first things I need to decide is, am I dealing with continuous numerical data or categorical data? In this case, because we are looking at different categories of different procedures, I'm definitely looking at categorical data, and therefore I will use a bar chart. Considering that there is some overlap between procedures for men and women, for example, both men and women have undergone blepharoplasty, mammoplasty, scar revision, and liposuction, I'm going to place those bars next to each other. Let me scroll down a bit so that I have more room. On the x-axis, I will have the categories. In this case, those are the surgical procedures. On the y-axis, I will have the number of procedures done in their millions. And now I can draw my bars. For an easier comparison, I have color-coded them. Blue for women and pink for men. I know, I'm messing with your minds. By presenting the information visually, it is easier to compare the differences between the number of individual procedures as well as the differences between procedures chosen by women and men. Let me explore another example. This time, I'm looking at the carbon dioxide emissions in Australia. According to the Australian Department of Climate Change, Energy, the Environment and Water, the carbon dioxide emissions in megatons for the period between 2013 and 2023 were as given in the table below. If I'm going to present this data visually, again, I need to decide, is this continuous numerical data or are we talking about discrete and categorical data? In this particular case, we are looking at continuous numerical data. Years represent time. Time is continuous. The mass in megatons is a measured quantity. Measured quantities are also continuous. This means that rather than using a chart, I'm going to use a graph. On the x-axis, I will have time. In this case, time is expressed in years. On the y-axis, I will have the megatons of carbon dioxide. Note that I have used scale breaks on both the y and the x-axis. This was done in order to fit the graph on the surface available. What are the points that I'm going to plot? Well, each entry in the table represents an ordered pair. So for example, the year 2013 and 140 megatons, that is an ordered pair. That is a coordinate. Let me quickly plot these points. Considering that this case deals with continuous numerical data, the individual points can be connected, and we end up with this curved line. To make everything neat, I am also to give this graph a title: Australian carbon dioxide emissions in megatons. Let me explore one more example. This time we have two companies. A fruit packing company that pays $30 per hour and $2 for each fully completed crate. The vegetable packing company pays $20 per hour and $4 for each fully completed crate. Both companies also offer proportional pay for partially completed crates. In other words, if you complete half a crate, you will still get paid. The question here might be, which company offers better pay? A visual representation might help. Am I dealing with continuous numerical data or discrete and categorical data? We could make the argument that money is continuous. It can be sliced into somewhat finer pieces. Dollars can be expressed in cents. What about crates? Surely crates are discrete. Absolutely. Crates come as whole numbers, but we are told that we will receive proportional pay for partially completed crates, which means I can deal with 1.1, 1.2, 1.3 crates. So here, crates can be treated as continuous as well, which means I'm going to use a graph to deal with the information presented. And if I'm going to use a graph, I need some points to plot. Where will they come from? Well, I'm going to generate some, and I'm going to use the information given. The best way to deal with this is to create a little table. And here it is. We have number of crates, money paid by the fruit company, and money paid by the vegetable company. In case of the fruit company, we are going to receive $30 per hour, even if we do not fully complete a single crate. So beneath 0 crates, I can write $30. If I fully complete one crate, I will end up with $32, because each fully completed crate at the fruit packaging company is an extra $2. In case of the vegetable packing company, I will receive $20 even if I do not fully complete a single crate. However, if I manage to complete one, I will end up with $24, because at the vegetable packing company, each crate will get me another $4. Let me finish this table quickly. Now that I have these values, I have coordinates or ordered pairs that I can plot on a graph. What should go on the x and what should go on the y-axis? Well, the pay is dependent on the number of crates. This means that the number of crates is the independent variable and will go on the x-axis. And that leaves money as the dependent variable, which will go on the y-axis. As I am plotting dollars versus number of crates, that might as well be the title of this graph. Alright, now I can plot my points. I'm going to start with the points for the fruit company. And here they are. At 0 crates, we are going to receive $30. At 1 crate, $32. At 2 crates, $34, and so on. Given that this is continuous numerical data, we can connect these points with a line. Now I'm going to plot the points for the vegetable company. Here they are as well. At 0 crates, we will get $20, with 1 crate, $24, with 2 crates, $28, and so on. Once again, I can connect these points with a line. These two lines have a point of intersection. And granted, we could have also identified that in the table over here. At 5 crates, both the fruit company and the vegetable company will pay $40. But looking at the graph, it is now easier to see that after 5 crates, working for the vegetable company, or more precisely, completing more crates at the vegetable company, will give us more money. That is all for now, and I will see you on the flip side.